In the next couple of sections, we're going to look at organometallic reagents and their behavior with carbonyl compounds. So remember, organometallic reagents that we've looked at are Grignard reagents, RMGX, and organolithium reagents, RLI. And these are made from corresponding alkyl halides. Recall, if you take an alkyl halide and you treat it with magnesium in ether, typically, or THF, or some solvent that has no water present, you can generate a Grignard. So a Grignard is RMGX. You can also generate organolithiums by taking an alkyl halide or an aryl halide or an alkenyl halide, reacting it with two equivalents of lithium, and that produces RLI, so organolithiums. You also generate lithium halide as a salt. Now, the thing about organometallic reagents, these Grignard reagents and organolithium reagents, is that they are very poor nucleophiles. They will not react with alkyl halides. If we think about this for a second, if I had a Grignard reagent, so RMGX, it is a base, right? We've seen reactions where the Grignard reagent reacts with water, behaves like a base, removes a proton from water, you generate an alkane. So it's certainly conceivable to react it, that if it's a base, it could also be a nucleophile. If it was a nucleophile, it would react with an alkyl halide. The result would be the formation of a carbon-carbon bond. And so you could possibly generate alkanes this way, which would be very important to be able to do. However, this reaction does not happen, which tells us it's not a good enough nucleophile to at least react with alkyl halides. There is a way to do this, and that way is using organocuprates, because organocuprates are nucleophilic enough to react with alkyl halides. Now recall, organocuprates are formed from organolithium reagents. You take an organolithium compound, you react it with copper iodide salt, and you generate an organocopper reagent. Now this is not an organocuprate, there is a difference. This is an organocopper reagent. And unfortunately, organocopper reagents are not nucleophilic enough. But if you had a second equivalent of organolithium to the organocopper reagent, you generate a dialkyl copper lithium reagent. This is called an organocuprate. Organocuprates are good nucleophiles, and they'll donate an alkyl group, almost like a carbanion. And when they do, they regenerate organocopper reagents, which you can then regenerate if you have any more organolithium present in your reaction. Now, you have seen a reaction that's similar, that's also called an organocuprate, where if you take two equivalents of an organolithium and you treat it with copper cyanide, you get dialkyl copper cyanide dilithium compound. This is also an organocuprate. It's just that one of the cyanides doesn't come off as easily. And so the complex itself has a -2 charge instead of a -1 charge. And so the lithium cation is associated with a dianion instead of a monoanion. Now, we know that organocuprates will react with alkyl halides, and they form a carbon-carbon bond, right? So you see our organolithium, or our organocuprate reacting with an alkyl halide to give our R primed, where R primed is a different alkyl group. Notice you're also generating an organocopper reagent, which is not a good nucleophile, so it just hangs around unless there is more organolithium in your reaction mixture. Now, in order for this reaction to work, the halide, now I use as a generic term an alkyl halide, but the halide certainly could be chloride, bromide, or iodide, but it also could be a different leaving group as well. And in terms of the R group, it could be a primary alkyl group or secondary alkyl group. Tertiary alkyl groups don't work very well because they tend to lead to elimination reactions. So here I have an alkyl tosylate, and it's reacting with dimethyl copper lithium. So this is going to donate a methyl group. The methyl group is the nucleophile. And so notice it substitutes for the tosylate. I get a methyl group. So notice this is a great way of making different types of alkyl halide, of hydrocarbons, right? So alkanes. Now, metalhydrides are another type of organometallic reagent that undergo similar reactions to that of organometallic reagents. And we've seen that lithium aluminum hydride will react with water. It produces hydrogen gas, plus lithium aluminum hydride with a hydroxide coming off of that. And it will also it is somewhat nucleophilic in that it will react with methyl iodide to produce methane. But there aren't a whole lot of other alkyl halides that it reacts with. And as a matter of fact, we've come up with some very creative type of metal hydrides. This particular metal hydride is called lithium triethyl borohydride, and it actually will add or undergo a nucleophilic substitution reaction with a primary or secondary alkyl halide. And so you get a hydride as the nucleophile, and then the lithium salt, the borohydride salt of bromine that comes off of it. And like other Lewis bases, organometallic reagents add to carbonyls. And so this is one of the biggest reactions that we have with organometallic reagents. And we're going to spend the next couple of sections talking about these types of reactions.